save our planet. Account from scientists calculates methane emissions from freshwater sediments. An international team of researchers for the first time have estimated the methane gas being emitted by freshwater areas such as lakes and rivers. The study, recently published in the journal Science, showed that these emissions reduce the net absorption of greenhouse gases by land ecosystems such as forests by at least 25%.
According to lead author Professor David Baskvilken from Linkoping University in Sweden, whereas small methane emissions from fresh water bodies occur continuously, abrupt larger emissions may also occur that are difficult to measure. Team member Dr. John Downing of Iowa State University in the USA stated, "The bottom line is that we have uncovered an important accounting error in the global carbon budget. Acre for acre, lakes, ponds, rivers and streams are many times more active in carbon processing than seas or land surfaces, so they need to be included."
Meanwhile, numerous other surveys have found plumes of methane escaping from seafloor sediments beneath the Arctic Ocean and other underwater regions. Although cold temperatures and high pressure have kept the methane in a frozen state for centuries past, recent destabilization due to human-caused global warming could eventually trigger a widespread release of the potent greenhouse gas at a rate of 16,000 tons per year. Research oceanographer Dr. Tony Koslow from the University of California, San Diego, USA explained,
"If sea temperatures increase sufficiently, that would lead to the release of these methane clathrates, these frozen methane in the deep sea. And once that process starts, it would just snowball."
Oceanographers also forecast that such a release would generate too many methane-consuming microbes, creating an imbalance as they consume the water's dissolved oxygen and generate carbon dioxide. The resulting oxygen depletion and acidification of the oceans would disrupt ecosystems and form dead zones, which in turn would undermine a vital oxygen source for the entire planet. Dr. Koslow points to a major marine mass extinction event in the past.
One of the real concerns is that about 55 million years ago, the best available evidence is that much of the methane that was trapped in the deep ocean was released very suddenly in geological terms. And this led to a huge warming, and it actually led to the extinction of much of the life in the oceans. And when paleoecologists discovered this, only within about the last 10-20 years, it's really changed people's perspective on how climate change can happen very, very rapidly, and how it can happen through the release of this frozen methane. The key is that we really have to contain global climate change.
Our appreciation, international scientists, for informing us of the potentially catastrophic impacts of unleashing underwater methane. May we act swiftly together to mitigate global warming so that the biosphere and planet may be preserved.